Alright, well, I decided to conduct a little experiment here with these fans. As we've been told that we take a centrifugal type fan, and if you block the input for the output, power consumption will drop. So, I got my meter, I got my power supply. This fan is rated for half an amp, just about, at 10 volts. So I'll go by my meter here and get it up to half an amp. So there's give or take 500 milliamps. It's blowing a fair amount of air, so I cap it on the intake, and it drops to almost down to 340 milliamps. So we'll do the same for the output. And as you can see, it drops to about just over 400 milliamps, 405 or so. So that was to be expected. That's fine. Okay, here's a 12 volt propeller fan. It came out of a car, I guess. We'll bring it up to about 700 milliamps, and I'll just cover that with a piece of paper. Here it says it goes up, and it goes up to around 840 milliamps, just in a piece of paper. Not the best deal, but. And on the bottom, I'm not going to make a very good seal either, so it's kind of awkward. 740 milliamps. So I'm going to try the same thing with a computer fan. Let's see what happens. So I'll disconnect it here. I got this little guy for $1.50 at Princess Auto. Great store, by the way. It's rated for, I think, 100 milliamps at 12 volts. Looking right. Yeah, 0.1 amps. I think we're connected right here, so I'll put my power supply back on until I get, give or take, 100 milliamps. Okay, so it's unrestricted flow. Just drawing that. If I happen to put it down, so air's blowing that way, I'll put it down intake side first, and it drops by about 10 milliamps. So that's kind of strange. I'll do the same thing. I'll put it down on the desk on the output side, and it just barely rises by about 3 or 4 milliamps. Try it again. And that time it was only about 1. So once again, intake side, you can hear it spin up, which is kind of neat. The fan is, or the blades are spinning a lot faster when I do that. So I'll try the same thing with another computer fan. Likely going to give me the same results, but it's good to have just to check. So back. Red. Now this one's set to draw, I think, 0.16 or 160 milliamps, I should say. So I'll just crank her up until we see that. And this is at a 24 volt fan. It actually came out of a photocopier a while ago. Buzz, buzz, buzz. And we get 160. There we go. So I'll do the same with this. I'll put it down on the desk, and it drops by 16, 17 milliamps. And I put it the other way around, and it stays pretty much steady. So when it's back up to 160, unrestricted 160, 159, something like that, and it drops by, well, it pretty much stays the same. If I happen to just slow down the blades manually with my finger, being very careful of course, you see it rises substantially up to over 400 milliamps. So it can be reasoned that it's not really a protector circuit in the fan, that if it gets blocked then it keeps the same current so you don't burn up your fan. It must actually be in the mechanical design of the fan, which is kind of neat, I think. Rudy didn't really have much of an explanation, but said he'd look into it. So that's what happens with our fans. Thanks for watching.